Hello, in today's practice lab, I will create a small network. I must connect the network devices and configure those devices to support various WAN protocols. The first WAN protocol I will configure is PPP with CHAP authentication. I will also configure access lists to limit network access and determine the IP addresses that are used in NAT. I will also configure GRE tunnel to allow BGP updates between the east and west domains. I will also configure SNMP and span for network monitoring during this practice lab. I hope my videos are helpful for those who are seeking to be certified for the Cisco exams. If you like my videos, please subscribe to my channel and share it on your Facebook page and give me the thumb up. And please let me know if you have any suggestions, comments, or questions. I will gladly answer you back. On the description of this video, you will find two files, one for the packet tracer source file and the documents to walk you through the lab step by step until you finally will be able to verify the configurations you did during this lab. Herefore, I will start by configuring the network devices. On router 1 and router 3, I will configure the LANs first, and then I will do the links between the routers. So on router 1, enable configure terminal, the host name of router 1. Now the interface gig 01 with the IP address of 172.16.1.1 with /24 subnet mask, and the IP version 6 address of this interface of 2001 db8 abcd 1::1/64 IP version 6 address fe80 1. This is for the link local, and I will activate the port with a no shut. Next, I will configure router 3 here, also the LAN. Enable configure terminal, the host name is router 3, and the interface of gig 01 with IP version 4 address of 172.16.3.1 with /24 subnet mask, and the IP version 6 address of db8 3::1/64 fe80 3, the link local, and again to activate this port with a no shut command. Next, I will configure PPP connection. Router 1, back to router 1. Now I'll configure the interface on router 1. The interface of serial 000, and this is with the IP address of 10.1.1.1 with /30 subnet mask, and the IP version 6 of this interface of this abcd : a::1 64 IP version 6 address 81 for the link local. Next, I will set the encapsulation to PPP. Encapsulation PPP. Enter. Next, I will activate the interface with the no shut command. Next, I will configure CHAP authentication on the serial of 000 PPP, authentication of CHAP. Enter. Next, I will create a database entry for CHAP authentication. I'll exit from here, and the username, I'm configuring this on router 1, the username of router 2, and the password of Cisco. Next, I will configure loopback 1 as a simulated web server with user access. So on router 1, the loopback interface, loopback 1, and this is with IP version 4 address of 209.165.200.1 with /30 subnet mask, and the IP version 6 address of db8 2:1/64 IP version 6 address of FE80 1 link local. Enter. Next, I will enable HTTP server with the global configuration command, but unfortunately Packet Tracer doesn't support this command, but I will show you how it's been configured. Simply type IP HTTP and then server. Enter. But as I said, the Packet Tracer doesn't support it. Next, I will create a privileged user to access the web server. And once again, this is how you do it. User name, simply I'll call it web, give it privilege 15, the highest, and with the password of Cisco. So I'm done here with router 1. Let's move to router 2. Now on router 2, enable, configure terminal, the host name of, we call it simply router 2. Now the interface of serial 000, interface facing router 1 with the IP address of 10.1.1.2/30 subnet mask, and the IP version 6 of this interface of this ABCD A:2/64 IP version 6 address FE80 to link local. Next, I will set the encapsulation on the interface, encapsulation PPP, and I will activate the port simply with this command of no shut. Next, I will configure CHAP authentication on the serial of 000 PPP authentication CHAP. Next, I will create a local database entry application. I'll exit from here. The username on router 2, I'll call it router 1 with the password of Cisco. So I'm done with on router 2 with this interface connected to, or with this link with router 1 with PPP. Now I will do the other link or the other interface. Interface of serial 001. The IP version 4 address of this interface of 10.2.2.2 with /30 subnet mask 255.255.255.252, and the IP version 6 address of db8 abcd B:24 with /64 IP version 6 address FE80 : 2 link local. And I'll activate the port with a no shut. Next, I will configure router 3. On router 3, the interface of serial 001. And this is with IP address of 10.2.2.1/30 subnet mask. And the IP version 6 address of this interface of this DB8 ABCD B:1/64 IP version 6 address 3 link local, and I will activate the port with a no shut command. Next, I will configure IP version 4 access control list for LAN, for this LAN here on router 1 and this LAN here on router 3. So on router 1, IP NAT inside source list 1 on the interface of serial 000 overload. Enter. Now we have the interface of gig 01. This is for IP NAT inside, and the interface of serial 000. This is IP NAT. Well, I'll keep typing, and NAT outside. Enter. So I configured NAT on router 1. I'll exit from here. Now I will configure an access control list for NAT translation to permit the network that is attached to the gig 01 to be translated. So access list 1, we want to permit the network of 172.1 172.16.1.0 with the inverse subnet mask of this for this LAN here on this side of router 1. Now I'm done here with on this LAN, so let's move to router 3 and configure this LAN here. Exit. IP NAT inside source list 3, because we are in router 3 on the interface of serial 001. We have the interface of gig 01. This is IP NAT for inside, and the interface of serial 001. This is IP NAT for outside. Exit. Now I will configure an access control list for NAT translation and will permit the network that is attached to gig 01 to be translated. Access list 3. We want to permit the LAN of 172.16.3.0 with the inverse subnet mask of 000.255. Enter. Next, I will configure IP routing. I will configure an IP version 4 default route to router 2 via the exit interface. I will configure an IP version 4 default route from router 1 to router 2 via the exit interface here. So on router 1, IP route to any network with this subnet mask and the exit interface of serial 000. Next, I will enable I will enable IP version 6 routing, IPv6 unicast routing. And now I will enable EIGRP version 3, IPv6 router, EIGRP with autonomous system 1. The router ID on router 1 of 1.1.1.1. Exit. Now I will configure the appropriate IP version 6 interface for the EIGRP, the interface of gig 01, IP version 6, EIGRP 1, and the interface of serial 000, IP version 6, EIGRP 1, and the loopback of 1, IP version 6, EIGRP at autonomous system 1. So now we are done doing EIGRP version 3 on router 1. I will do the configuration on router 2. Now I will enable version 6 unicast routing, IP version 6 unicast routing. Next, I will enable EIGRP version 3 routing and router ID on the router, IP version 6 router EIGRP autonomous system 1, EIGRP the router ID on router 2 of 2.2.2.2. Enter. Next, I will configure the appropriate IP version 6 interfaces for EIGRP. I'll exit from here. On the interface facing router 1 on serial 000, IP version 6, EIGRP 1, and the other interface of serial 001 facing router 3, IP version 6, EIGRP at autonomous system 1, and enter. Next, I will configure IP version 6 routing on router 3. First, I will configure an IP version 4 default route to router 2 via the exit interface with the administrative distance of 200. So go to router 3, IP route to any network with this subnet mask and the exit interface of serial 001 with the administrative distance of 200. Next, I will enable IP version 6 routing, IPv6 unicast routing. Next, I will enable EIGRP version 3 routing and the router ID on router 3, IP version 6 router EIGRP with autonomous system 1, EIGRP router ID on router 3 of 3.3.3. Exit. Now I will configure the appropriate IP version 6 interface for the EIGRP. We have two interfaces, the interface of serial 001 facing router 2, IP version 6, EIGRP with autonomous system 1, and the other interface of gig 01, IP version 6, EIGRP 1. Now, let's verify network connectivity. Now from PCA, I will ping PCB. From this guy here, I want to ping this PC with IP version 4, ping 172.16.3.10. It's unreachable. Now let's ping IP version 6, ping 2001, ABCD 3::10. It's not successful. Now I will ping from PCA to router 3 interface, ping 10.2.2.1. From here to this interface here. Now I will ping from PCB to BCA and it shouldn't be successful. Ping should fail 172.16.1.10. It's unreachable. Also, I'll ping IP version 6, ping 2001, DB8, ABCD, 1, colon, colon, 10, and it is also not successful. And from PCB, I will ping this interface here, and it should be successful. Ping 10.1.1.1, and it was successful. Now, from PCA, I will ping the loopback or the simulated web server. Ping 209.165. It should be successful, but 200.1, and it is. And the IP version 6 of 2001, DB8, ABCD, 2, colon, colon, 1, and this should be successful, and it is. Now, from BCB to the simulated web server should not be successful. Ping 209.165.200.1, and it is not. And the same with IP version 6, 2001, DB8, ABCD, 2, colon, colon, 1, and it is not. Now, we will be able to, after we configure the tunnel, next, I will configure a GRE tunnel with BGP with routing on router 1 and router 3 and tunnel 0. So on router 1 here, I will exit interface tunnel. We can have tunnel numbers up to this huge number, but I'll use number 0. The interface, the IP address of, here we have 8.8.8.1 with /30 subnet mask, 8.8.8.1, 255, 255, 255, 252. Now I will set the tunnel source interface, the tunnel source of serial 000. This is the source here for the tunnel on this, and now the destination will be this IP address. Next, I will set the tunnel destination IP address, tunnel destination of 10.2.2.1. Exit. Next, I will set the host route or route to the tunnel destination with a /32 mask, and I will use the exit interface. Now, host route or route from here to this is the destination, and with a /32 mask. So back to router 1, simply type IP route or route to the 10.2.2.1 with the /32 mask, 255.255.255.255, and the exit interface of serial 000. This is our exit interface. Next, I will configure BGP, the autonomous system of 65010 on router 1. Router BGP with autonomous system of 65010. Enter. Next, I will configure the neighbor statement, which is the tunnel on the other side. So on the tunnel for here, this is our neighbor. here, and this is the autonomous system of our neighbor, the other side of the tunnel. The neighbor of 8.8.8.2, and this is with a remote autonomous system for this of 65030. 65030. Enter. Next, I will configure network statements only for networks connected to the loopback 1 and the interface of gig 01. This is the network of this and the loopback on router 1, the network of 172.16.1.0, and this network is with a mask of 255.255.255.0, and of the loopback of 209.165.200.0, and this is with a mask of 255.255.255.252. Enter. Next, I will configure GRE tunnel with BGP routing on router 3. We are done here, so we will move to this guy here on router 3. Exit. Now, the interface of tunnel 0, just the same number as we configured on router 1. And this is with the IP address of 8.8.8.2 with /30 subnet mask 252. Next, I will set the tunnel source. Tunnel source, the source of interface here of serial 001. Now, the tunnel destination IP address of, this is the destination, this interface of 10.1.1.1. Enter. Now, I will set the host route to the tunnel destination to this interface here with a /32 mask, just like we did on router 1, and I will use the exit interface of serial 001. So the command goes like this: IP route to 10.1.1.1 with /32 mask 255.255.255, and the exit interface of serial 001. Next, I will configure BGP as the autonomous system of 6503. Router, BGP, the autonomous system, here of 65030. 65030. Enter. Next, I will configure neighbor statement. This is our neighbor here. For on this router for the tunnel, this is the neighbor. So the neighbor of 8.8.8.1, and our neighbor is with the remote autonomous system of 65010. Next, I will configure network statements on 4 network connected to gig 01. So the network of 172.16.3.0, and this network is with a mask of /24. Next, let's verify connectivity or network connectivity so far. So now let me ping from PCA to the simulated server, from here to this guy, to the loopback, or our simulated server. And it is successful. And from PCA to BCB, the up arrow, 172.16.3.10, and it is successful. And you can ping from PCB to the simulated web server and to PCA. Next, I will implement PPP over Ether, the point-to-point over Ethernet PPPoE is a network protocol for encapsulating PPP frames inside Ethernet frame. I will configure PPPoE on router 2. So on router 2, enable, configure terminal. Now I will configure a username with a password. Username, customer or cust1 with a password of Cisco. Now I will configure local pool name. I will name it pool caps. The pool will be from 20.0.0.1 to 20.0.0.10. IP local pool, I will simply name it just pool 20.0.0.1 to 20.0.0.10. 10 IP addresses. And hit enter. Now I will configure the interface virtual template. The interface of virtual template 1. Now if I try to type IP address of 20.0.0.254 with this subnet mask, .0 and hit enter. Unfortunately, packet tracer does not support this command. IP unnumbered on the gig 00. Next, I will configure the MTU at 1492. MTU stands for Maximum Transmission Unit. It is the largest size packet or frame, specified in octets, 8 bits byte, that can be sent in a packet or frame-based network such as the Internet. The Internet's Transmission Control Protocol TCP uses the MTU to determine the maximum size of each packet in any transmission. If I type MTU, it's unfortunately here the packet tracer does not support it, but I will show you how to just type MTU if you use a different software like GNS3 or the actual router. 1492 and hit enter, but packet tracer does not support this command. Now peer, the default IP address pool, and we named it pool. Next, I will configure the authentication CHAP, PPP, authentication CHAP, just simply colon, enter. Now, I'll exit from here, BBBA, group, PPP over Ethernet, global, enter. The virtual template 1, enter, and I will exit from here. Next, I will enable PPP point-to-point over Ethernet on the interface of gig 00 on router 2, which is this interface here. This interface here. Now, interface gig 00, PPP point-to-point over Ethernet, enable group global, enter, and I will activate it with a no shot. Next, I will configure router 3 as point-to-point protocol over Ethernet client. So go to router 3, exit here. I will configure this interface of gig 00 here, this side on router 3 as client or PPPoE client. On global configuration, I interface of gig 00, PPP over Ethernet, enable, and enter. And the client uses dial pool number of 1. PPPoE, client, dial pool number 1, enter. Next, I will activate the interface, no shut. And I will exit from here. Next, I will configure the dialer interface 1. Interface dialer 1. Next, I will negotiate the IP address from router 2. IP address negotiated. Enter. Next, I will reduce the MTU to 1492 to accommodate the PPP headers. Here, MTU 1492. Enter. And encapsulation PPP. Enter. Next, I will create dialer pool 1. Dialer pool 1. And then hit enter. Next, I will create, I will enforce and assign the CHAP authentication. PPP authentication, CHAP, colon, username admin3 and password is of Cisco. PPP, CHAP, hostname admin3 and PPP CHAP password of Cisco. Enter and activate it with a no shut and then exit. Next, I will configure a static default route using the dialer 1 as the exit interface. Now, IP route or route to any network with this subnet mask, and I will use dialer 1 as the exit interface. Dialer 1 and then hit enter. Let's see network connectivity so far. From PCA, I will ping PCB. And it is successful. And from PCA, I'll ping PCA. And it is successful. Next, I will configure IP access control list. I will configure IP version 4 extended access list named West. I will deny all ping to router 1 LAN. So now on router 1, here, enable, configure terminal, IP access list, extended, and I will simply call it West. Enter. I will deny all the pings or ICMP from any to any. Echo. but I will permit any other protocol from any to the router. Exit. Next, I will place the access control list at the correct interface and direction, which is our interface of gig01 here, because we don't want anybody pinging this LAN. The interface of gig01. IP access group, we called it west out, from the router out to the LAN. Enter. Now, let's see if we can ping from PCB to PCA. And we shouldn't. And it's unreachable, which means our configuration is correct. Next, I will configure IP version 6 extended access list. I'll name it East on router 3, and I will deny all pings to network. The network of IP version 6 here of 2001 DB8 ABCD 3::/64. This network here. So on router 3, IP version 6 access list, I'll call it East. Enter. I will deny the ICMP from any to this network 2001 DB8 ABCD :3:/64 echo request. I will deny any ICMP to this network, but I will permit any IP version 6 from any to any. Exit. Next, I will place the access control list at the correct interface and direction, which is on the interface of gig01. And IP version 6 traffic filter, we called it East out. You can just determine by running pings from PCA to PCB. I will just skip to our next, because I don't want this lab to take lots of time. Now I will configure SNMP version 3 on router on router 1. I will do the configurations for SNMP version 3 using an access list on router 1. I will show you how you can do this, but unfortunately packet tracer does not support it, but I'll show you the commands. Maybe you want to run this command, this lab on a live devices or using GNS3. I will create a standard access list to permit only the LAN containing PCA named access. So here on router 1, first exit on the global configuration, IP access list, standard, I will call it simply access. I will just show you how you can do these commands. Now we want to permit the network of 172.16.1.0 with the inverse subnet mask of this to permit the LAN on router 1, and I'll exit from here. Next, using the SNMP server view command, which unfortunately packet tracer does not support it, but I'll type it anyway. I will configure an SNMP if view include a specified MIB, which stands for Management Information Base, SNMP view, which is caps SNMP-read only, and the MIB included, which is ISO. So the command, you type it like this: SNMP server view SNMP read only ISO included, and then hit enter. But as I said, unfortunately, packet tracer does not support it. Next, using the SNMP server group command, I will configure SNMP group, SNMP version with authentication and encryption, and limit access using access control list. The command goes like this: SNMP server group version 3 pri read SNMP read only access, and we named our access control list as access. This is how you type the command and then hit enter. But as I said, packet tracer does not support it. Next, using the SNMP server user command, I will add an SNMP server as a member of SNMP using SNMP version 3 with authentication and encryption. So you type the command like this: SNMP-server user, I'll call the user Dave, for example, SNMP version 3 authentication SHA, call it here Cisco A pri AES 128 Cisco B. Enter. Sorry about that. And as I said, packet tracer does not support this command. Next, I will configure span on switch 2. I'm sorry about that, packet tracer. Hopefully with the upcoming or future versions it will be able to support these commands, but I just want to show you how to configure this. Now I will configure span on switch 2. Span, which stands for switched port analyzer. Port mirroring, also known as span, switched port analyzer, is a method of monitoring network traffic with port mirroring enabled. The switch sends a copy of all network packets seen on one port or an entire VLAN to another port where the packet can be analyzed. So now here on switch 2, enable, I will issue the span command to monitor the traffic on switch 2, the session number 1, and the source switch port on switch 2 is the F03 here. So on switch 2, the interface, configure terminal, interface F03. First I will activate it, no shut, and I will exit, and then type this command: monitor session 1. The source is the port of FAT Ethernet 03. Sorry, interface. Next, I will issue the span command to capture the traffic on switch 2, session number 1, and the destination port, the switch port on the Fast Ethernet 018. So on the interface of 018, I will activate it, and then I'll exit, and then type the command monitor session 1, The destination will be on the interface of F018. Enter. This is the connection to the PC. Next, I will enable the connection between switch 2 and router 2 on this interface. From switch 2 to router 2, this should be F011. I'll type it here, F011. Here. I just enable it. The interface of F011, activate it or with no shot. Now, when you are done here, just run these commands, you know, on switch 2, show span, and you have so many options here. Type in active and then detail and inconsistent ports, interface, summary, VLAN, and just type this command and study each one individually so you can have an idea how to run this command. I hope you learned something or two from this video. Sorry about the SNMP version 3 that packet tracer does not support it, but I tried, you know, just to show you in case if you use a live equipment or GNS3 that how to run these commands. Everything is listed in the walkthrough documents. I hope you like this video. Please, if you like it, subscribe to my channel and share this video on your Facebook page. Let others just to know them about this video. And I will starting really soon with the new for the new exams of Cisco exams. I need your support so I can have whatever suggestion you have, what videos you want me to do, and I will do it. Thank you so much for watching, and I'll see you in my next video. Have a nice day.